Welcome to this video lesson on vectors between 2 points. Some of the prior knowledge that will help us through this lesson are basic trig algebraic operations, geometric operations, and finally magnitude of a vector. Let's start with an example. We're going to draw a coordinate system which kind of represents a classroom, and x is going to be the east direction and y is going to be associated with the north direction with reference to the corner of the classroom. Then we are going to label 2 points. The first point is going to be our initial position, and then we're going to move to our second point, which is our final position. The first point is going to be located 2 meters to the east of the corner and 4 meters to the north of that corner, and the final position 12 meters east and 8 meters north. The displacement, or how much we have moved, is going to be represented by a vector which starts from our initial position to the final position. We can figure out the components of this vector, which represents the components of our displacement, from these 2 points. For the east component, all we have to do is figure out how much we moved in the east direction. So we subtract the final east position, which is 12, by the initial east position, which is 2, to get 10. And for the north direction, or the y direction, we subtract the final north direction, which is 8, by the initial y direction, which is 4. And that will give us 10 for the east and 4 for the north component. Now, if you want to do this in a general case, we can have 2 points A and B, and A is going to have its x component and the y component represented by AX and AY in this case, and B is going to have its x and y component represented by BX and BY. To figure out the vector between these points, vector AB, that for the x component we subtract BX by AX, and for the y component we subtract BY by AY. We can show this using another method as well by using vectors. So position vector A is from O to A, and it will have components AX and AY. And vector B will be, position vector B will be OB, starting from the origin, terminating at B with components BX and BY. We can note that if we were to add vector A, which originates at O and terminates at A, to vector AB, which originates at A and terminates at B, we would get position vector B, which originates at O and terminates at B. We can do a rearrangement for vector AB. It's going to be position vector B minus position vector A, and that means B's components minus A's component, and that will give us vector AB's x component as BX minus AX and its y components as BY minus AY. A very quick example, let's determine vector AB given the 2 points, point A having components 3 and -5, and point B having x and y components of 1 and -1. To find vector AB, we're going to subtract the 2 x components of the point, so point B minus point A for x and y, so we get 1 minus -3 for the x components, giving us -2, and -1 minus -5, giving us 4 for the y component. Here's a very quick summary. If we have a vector that originates at A and terminates at B, we can find its component by subtracting the x component of the point B by the x component of point A, and we can find the y component by subtracting the y component of point B by the x component of point A. Let's do a couple of examples. In the first example, we want to determine the coordinates of point B given that vector AB has an x component of 4 and y component of -1, and that point A has x component of -1 and a y component of 3. To solve this, we know that vector AB will have components BX minus -1, which is the x component of point A, and by minus 3, which is the y component of point A, and that's going to equal to vector 4, negative 1. So for the x components, bx minus negative 1 is going to be equal to 4, and for the y component, by minus 3 is going to equal to negative 1. We will solve this, so bx plus 1 is equal to 4, so bx is going to equal to 3, and by minus 3 is negative 1, so by is going to equal to 2. So the x component of point B is 3, and the y component is equal to 2. For the second question, we are going to have a parallelogram, and we want to determine the following. First, we want to figure out vector BA, CD, and hence, using the information from previous questions, we want to figure out the coordinates of point D. Okay, so for vector BA, it originates at point B and terminates at A, meaning that the x component of the vector is going to be the x component of point A, which is negative 8, minus the x component of point B, which is negative 3, and its y component is going to equal to the y component of point A, which is 0, minus the y component of point B, which is 8. Do the calculation, negative 8 minus negative 3 is negative 8 plus 3, which is negative 5, and 0 minus 8 is negative 8. And we can check our solution. We can see that on the vector itself, we can see that from B, we're moving to the left and we're going down. So the negative 5 and the negative 8 actually does make sense. For part B of the question, vector CD originates at C and terminates at D. We can see that the two sides of the parallelogram are the same in terms of magnitude, and they're going in the same direction, meaning vector CD is equal to vector BA. We know vector BA already, it's negative 5, negative 8 from the last question, and we do need to say that this does make sense because it's a parallelogram, meaning that the two sides have the same magnitude and the same direction. Now for part B, we want to find coordinates of point D. We already have vector CD, and since we have the vector in one of the points, we can find the other point. So we want to subtract the x component of point D by the x component of point C, which is 10. And we want to subtract the y component of point D by the y component of point C, which is 6. And that's going to equal to vector CD, which is negative 5, negative 8. Now we're going to separate the x component, dx minus 10 is equal to negative 5, and the y component, dy minus 6 is equal to negative 8, and we're going to solve for those two coordinate points. So dx is going to be negative 5 plus 10, which is 5, and the y component of point D is negative 8 plus 6, which is negative 2, and we will write this in the point form, which is going to be d bracket 5 comma negative 2. For the last question in this video, we are given vector AB with components 1, 4, and vector CA with components negative 2 and 1. And based on those, we want to determine the vector CB. We're going to do this by drawing out our final vector, which originates at C and terminates at B. And to get there, we need to originate at C, get to some point, in this case point A, and then from that point A, go to point B. So this is same as writing it as vector CB is equal to vector CA plus vector AB. And point A is that point that's being shared between the two vectors in between. Once we have this, we know vector CA has components negative 2 and 1, and we know vector AB has components 1 and 4. And we'll put them together. We'll add the components. The x components become negative 1 and the y component becomes 5. Now there's a side note here to show you the connection between algebraic and graphical operations of addition of vectors. So let's say we wanted to add vectors A, B, B, C, C, D, and D, E. We originate at point A, go to B, and then from B to C. This gives us vector AC, getting rid of point B in terms of our addition. Then we add CD, and now our vector originates at A and goes to D, eliminating point C. Finally, we go from D to E, and our final vector goes from A to E, kind of eliminating that middle section, which is point D. So our final vector is kind of like the original point, which is A, and the final point, which is E. And every single point that have been shared in terms of additions are removed. Sometimes we can use this trick in subtractions as well. So BA minus vector KA is same as vector BA plus AK, because negative KA is equal to positive AK. And once we have that, the middle point's A is removed and we get vector BK as our final answer. I will leave you with some practice questions to do, and I will try to post the solutions to these as soon as I can. I hope that this video was helpful to give you an understanding of how to find a vector between 2 points and how to algebraically and geometrically connect the idea of addition of vectors. Thank you for watching.